All right, today we are going to talk about graphing the cosine function. Okay, so for your cosine function, the graph of the, this looks like this is a picture of the cosine function. You can tell, it looks just like the sine function. It just waves exactly like the sine function. The difference is sine would do this. Sine would start at 0, and then at pi over 2, it goes up to its amplitude, and then down to 0, and then down to down amplitude, and then back to 0. So this would be sine. And you can see cosine looks exactly the same. It's just shifted over pi over 2 units. Okay? So what ends up looking like in the red is one period of sine. And let me get a different color here. In green, for cosine, instead of starting at 0, 0, you start at 0 amplitude. For mother cosine, B is 1. You have just cosine x, mother cosine. The amplitude is 1. So instead of starting at 0, 0, you start at 0, 1. And then the next mark, you go to 0. Then at pi, you go down to the amplitude. At 3 pi over 2, you come back to 0. And at 2 pi or 4 pi over 2, you go back up to the amplitude. So in green, that's one period of cosine. Cosine kind of looks like a big bowl, whereas sine looks like up and down and back. This is just down and back. Okay? So there's one period of cosine x. Alright, so your amplitude is going to be the absolute value of a again. Your period is still going to be 2 pi over b. Okay, the domain is negative infinity to infinity. Just like sine, the range, these oscillate between positive 1 and negative 1 unless you change the amplitude. Okay, and the period is 2 pi. Cosine is actually an even function. Okay, because if you reflect it over y, it looks exactly the same, whereas sine is an odd function. Alright, so it says how to graph cosine functions of the form y equals a cosine bx. In other words, there's no horizontal or vertical shift. If there's no horizontal or vertical shifts, you find your amplitude, you find your period, you find your scale, you mark the draw the coordinate system, you put 4 lines on your x-axis, alright, and then for sine, mark your amplitude. And then for cosine, you're going to start at the amplitude, 0 amplitude. Then you're going to come down to the next mark, 0. The next mark is down amplitude. Then the third mark is back to 0. And the fourth mark is back to amplitude. And then you connect it, and there is how you graph a cosine function. Okay, so here we go. It says determine, did I skip one? Yeah. Determine the amplitude of each function, then graph the function and y equal cosine x in the same rectangular coordinate system for 0 less than or equal to x less than or equal to 2 pi. That means they want me to graph from 0 to 2 pi. Alright, so we've got our amplitude. Oh, they want me to draw cosine. Cosine starts at 0, 1. Then goes down to 0, then down, oops, that's 1, that's negative 2. Then goes down to down amplitude, then 0, then up amplitude. So there would be mother cosine. This thing is going to reflect over x and have a vertical stretch. So it's going to be deeper, or the bowl is going to go deeper, and it's going to reflect over x. So your amplitude is going to be the absolute value of a, which is the absolute value of negative 2, which is 2. My period is going to be 2 pi over b. b is 1, which is 2 pi. So my scale is going to be 2 pi over 4, which is pi over 2. So my scale goes 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. And notice that I finish at 2 pi. So then after that, once you have your scale, you plot your points. Well, get a different color. How about purple? Let's do like this. Normally you start at 0 amplitude. Well, my amplitude is 2, and because it's negative, we're actually going to start down amplitude. then we're going to go to 0, then we're going to go to up amplitude, then we're going to go to 0, then we're going to go to down amplitude. So if I connect that, and if you notice, it's much steeper. See the distance between green and the axis and blue and the axis, it's stretched by 2, and it reflected over x, so it went up first instead of down first. Okay? Alright, so if we try this one, it says they want me to graph, this one does not say I have to graph regular cosine, so we're just graphing this one. So my amplitude is the absolute value of -4, which is 4. So 1, 2, 3, 4, -1, 2, 3, 4. My period is going to be 2 pi over b, which is 1/2. Keep, change, flip is 4 pi. So to get my scale, I take my period, 4 pi, cut it in fourths, which is pi. So I'm going to count by pi's. 1 pi, 2 pi, 3 pi, 4 pi. And after that, I can graph. And what I do is, I normally would start at 0 amplitude, but because my amplitude is negative, it reflects, so I'm going to start at 0, -4. The next mark would be 0, the next mark would be up at your amplitude, the next mark 0, the next mark down to amplitude. And connect, and there's your upside down cosine with a stretch of 4 and a period that is stretched by 2. Remember, normally cosine finishes by 2 pi, so normally that picture would be within this interval. But they stretched it by 2, so instead of ending at 2 pi, it didn't end until 4 pi. And then the 4 obviously stretched it up to 4 instead of normally at 1 and -1. Okay? Alright, let's look at one where we're going to have a vertical shrink, a reflection over x, and some variation of my period. Let's see what it is. My amplitude is the absolute value of -1/2, which is 1/2. My period is going to be 2 pi over b, which is pi over 3. Keep, change, flip. That gives me 6 pi divided by pi, which gives me 6. Okay, so my period is going, or my scale is going to be my period, which is 6, divided by 4, which is going to be 3/2 if I reduce. So we're counting by 3/2. 3/2, 6/2, 9/2, 12/2. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, and the denominator stays the same. So, and of course, 12 divided by 2 is 6, which is where my function should end, or a period of my function should end. Alright, so if I graph this now, we got to have our amplitudes, which is at +1/2 and -1/2. Because of the negative, instead of starting at up amplitude, I start at down amplitude. The next mark would be 0, the next mark would be up amplitude, then 0, then down amplitude. And I get like this. I don't know why we're doing all negative ones, but... And there you go. Alright. So what happens when we do have a horizontal or vertical shift? Well, what you do is the same thing that we did for sine. You still find your amplitude, your period, your scale, but now you've got an extra step. You have to find your phase shift, which will still be C divided by B, and your vertical shift will be D. Alright, so you mark your x-axis with 5 marks this time instead of 4. Be careful, because sometimes you might have to start on this side, but you need a total of 5 marks. Alright, your first mark is going to be whatever the phase shift was, plus or minus, or, well, no, it's going to be whatever the phase shift is, C over B. The y-coordinate is going to be whatever your amplitude is, plus or minus your vertical shift. That will make it go higher. We didn't actually do any that had a vertical shift on sine yesterday. We will today. Okay? And then your mark 2, mark 3, mark 4, you just follow the pattern. Once you get your first mark, then you just know you alternate between the amplitudes and zeros. Alright, so here we go. It says, determine the amplitude, the period, the scale, and the phase shift, then graph one period of the function. So we need our amplitude, which is the absolute value of 3, which is 3. Notice how we don't have a vertical shift, so I know that I don't have to worry about going any higher or lower than -3, because there's nothing added on to the end of the function, so there is no vertical shift. All right, my period is going to be 2 pi over b, which is 2, which would give me pi. My scale then is going to be pi over 4. Yeah? All right, so, but I don't want to label my scale yet because I got to find out what my phase shift is going to do. My phase shift is going to be c, which change the sign is positive pi. If that was a plus, you'd use negative pi, over b, which is 2. So my phase shift is pi over 2. Alright, so watch. I'm going to start at pi over 2, but I got to count by pi over 4s. So I still am going to write my scale pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4, because I need 5 marks. And I'm going to shift, I'm going to start, my starting point is going to be pi over 2. So if I start at pi over 2, which would be 2 pi over 4, for cosine I'm going to start at my amplitude. So right there would be my amplitude. At that point then, I mean you got to figure out your scale, but if I take pi over 2 and I add pi over 4, if I get a common denominator, that would be 2 pi over 4 plus pi over 4, which would be 3 pi over 4. So, and that's what I'm counting by. And then if I added another pi over 4, that would be 4 pi over 4, which is this mark. Add another pi over 4, that would be 5 pi over 4, which is this mark. So we've got our scale right, we've got it marked right, but now my starting point is here because I'm going to shift to the right pi over 2 units, which I did. So now you just follow the pattern. Up amplitude 0, down amplitude 0, and I'd actually need 6 pi over 4 to finish this, to back up to alright, 3 pi, 4 pi, 5 pi, 6 pi. Yeah, that should have been 6 on my paper. Okay, so then we go bloop, bloop, bloop. Alright. And guys, you're going, but wait, the period was supposed to be pi. Yeah, well, it started at 2 pi over 4, it ended at 6 pi over 4. If you say 6 pi over 4 minus 2 pi over 4, you get 4 pi over 4, which would be a total of pi units. And that finished one cycle in one period of that cosine function. Alright, so let's try this one. We're going to have an amplitude of 1/2. And there's nothing added on or subtracting, so I know it's only going to go as high as 1/2 and as low as negative 1/2. My period is going to be 2 pi over b. Okay, I can't reduce it, so my scale is going to be 2 pi over 3 over 4. Keep, change, flip gives me 2 pi over 12, which gives me pi over 6. Before I start labeling my scale, I got to figure out my phase shift. Alright, so my phase shift is going to be c, which is pi over 2, divided by b, which is 3. So keep, change, flip, and I get pi over 6. So I have to start at pi over 6 and count by pi over 6s. So that works out nice when they match. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. I think I'm going to have to go out to 6 pi over 6. I don't know. Okay, so my first mark is at pi over 6 now. And for cosine, you go to your amplitude first. No negatives, so I'm not reflecting, so I go up to my amplitude. And then I count by pi over 6s, so my next pi over 6 would be 0, my next pi over 6 would be negative 1/2, my next pi over 6 would be 0, and my next pi over 6 would be amplitude. That completes one period of cosine. Yeah. Yep. Alright, so let's try this one. This one isn't going to come out so pretty. Okay, so we're going to find the amplitude, which is 2. And then we are going to find the period, which is 2 pi over b, which is 2 pi, which is 1. And my scale is going to be 1/4. My phase shift is going to be c, which is 8 pi, over b, which is 2 pi. Oh, sorry, it's not positive 8 pi, it's negative 8 pi, because remember you changed the sign. And that gives me a -4. So I can't even start this until -4. Alright? And this is going to be in my way. Can't start this until -4. So if I call it, I'm going to start at -4, and I'm going to add my scale to it. So if I take -4 and I add 1/4, I get, oh wait, my first point is actually going to be at -4. Let's see my 5 points. What's my amplitude? 2. So -4, -2 is my first point. Okay, to get my next point and my scale marking, by the way, I'm going to take my -4 and I'm going to add a 4th to it, and that ordered pair would be at 0 because the next one would be at 0. The next one, I'm going to take -4 and I'm going to add 2 scales, so 2/4, and that would put me at negative amplitude. My next mark, I'm going to add 3/4, comma, that's going to put me up at, -2. No, we start at +2. Sorry, because we're not reflecting. So then we'd go to 0, then we'd go to down amplitude, then we'd go to 0, and then my -4 plus 4 scales would be back at my amplitude, which would be +2. So if I get decimal equivalents for those, because I know you guys hate fractions, I get -4, 2, I get -3.750, I get -3.5, -2, I get -3.250, and I get -3, 2. So when I do my marks, I have -4, I have -3.75, I have -3.25, and I have -3. And then you have -2 and -1 here, and 1, 2, so on and so forth. Alright, so at -4, I'm up at 2. At -3.75, I'm back to 0. At -3 point, I missed one. I missed 3.5 on my scale. Dang it. Oh my gosh. Alright, so you have -3.75, -3.5, -3.25. Why am I messing this up so bad? Let me try this again, guys, and draw this right. Alright, so if this is -4, we have -3.75, -3.5, -3.25, and -3. Alright, now let's try this. Alright, so -4, 2, -3.750, -3.5, -2, -3.250, and -3 will be up at 2. And notice I finished a period between -4 and 3. I finished a whole period within 1 unit. Okay? Alright, so let's try another one. These ones, now we're going to have our vertical translation. Okay? So you're going to find your amplitude, which is 2. You're going to find your period, which is 2 pi over b, which is 1/2. That's going to give me 2 pi, keep change, flip, gives me 4 pi. My scale is going to be 4 pi divided by 4, which is pi. And I have my d, there is no phase shift, but my d equals up 1. So basically what you do is, if I was graphing this, this would be pi, 2 pi, 3 pi, 4 pi, Alright, and let's see, I've got normally your ordered pairs. Now we're doing sine here. So normally it would be 0, 0. But what am I going to do to y? I'm going to add 1 to it. Alright, my next ordered pair would be pi amplitude. So it should be at 2. But again, that y coordinate, this affects y, so I'm going to add 1 to it. My next mark would be 2 pi and then back to 0, but my y needs a 1 added to it. My next point would be at 3 pi back to its down amplitude, which would be -2, but I've got to add 1 to the y. And my last point would be at 4 pi back to 0, but I got to add that vertical shift to y. So then what I have is 0, 1, pi 3, 2 pi 1, 3 pi -1, 4 pi 1. So if I plot those points, okay, 0, 1, yeah, 0, 1, sorry, my brain went a little fuzzy there, just checking myself. Okay, 0, 1, pi 3, 2 pi 1, 3 pi -1, 4 pi 1. And you can see that this thing was shifted up 1 unit. Because normally it would only go as high as 2 and as low as -2, but it's going all the way up to 3, and then that obviously brings this up 1 more unit. Okay, pretty cool. There's a sine with a vertical shift. Let's do a cosine with a vertical shift. Alright, this one is going to be reflected. Yeah, okay, reflected. So my absolute value of -3 is 3. My period is going to be 2 pi over b, which is 2 pi, which is 1. My scale is going to be 1/4. Alright, and I don't have a phase shift, but my vertical shift is going to be up 2. Alright, so normally if I was starting this at cosine, alright, and by the way, so you're counting by 1/4, so I don't have a phase shift. So 1/4, 2/4, 3/4, 4/4, 5/4, so on and so forth, yeah? So normally if I was doing cosine, my first ordered pair would be at 0 amplitude, which would be at 0, -3. But I've got to do what to my y? I've got to add 2 to it. My next ordered pair would be at 1/4, 0, but I've got to add 2 to my y. My next point would be at 2/4, up amplitude would be 3, but I've got to add 2 to my y. My next point would be 3/4, back to 0, but I got to add my vertical shift. And then I would have 4/4, which would be back up or back down actually at my down amplitude, but I've got to add 2 to that. Okay? So if I figure out these coordinates, I get 0, -1, I get 1/4, 2, I get 2/4, 5, I get 3/4, 2, and I get 4/4, -1. So if I plot these ordered pairs, I got 0, -1, 1/4, 2, 2/4, 5, 3/4, 2, 4/4, -1. And up and down. And there we go. Yeah. Alright. So, how do you find the period, midline, amplitude, phase shift, and vertical shifts of the cosine function? Well, your cosine function, you're going to have, let's see, y equals a cosine bx minus c plus d. So the period is 2 pi over b. the midline, again, now that we've had a vertical shift, let me back up and show you. You see how now my midline would be right here, which would be at 1 instead of 0. Normally your midline is at 0, unless you do a phase shift up or down, or I mean a vertical shift up or down. So now you can see my midline would be at 2. Mathematically, how you find that is you take your highest point, which should be your highest amplitude, and add it to your lowest amplitude and divide by 2. Amplitude is A, absolute value of A. Phase shift is C over B. And your vertical shift is D. Okay, so how do you graph vertical shifts in sine and cosine functions? You add D to your y coordinates. How do you graph the cosine function? You start at 0 amplitude, and then you would go to your next mark. I don't know how I want to put that. You'd go to your next mark. You go to mark 1, and that's going to be at 0. Then you're going to do mark 2 is at down amplitude. Mark 3 is back to 0, and mark 4 is back at amplitude, positive amplitude, and connect them. Given the graph of a trigonometric function, how do you determine the amplitude, period, and midline of the cosine function? Well, you read the graph. The amplitude, this is 7. The amplitude is the highest and lowest points. The period is still going to be 2 pi over b, but you'd have to look at the graph and see where it stopped. You know, when I did that one where I saw where it stopped and where it started, and I figured out that that was my period. And the midline will be halfway between your highest point and your lowest point. Okay, and we are at homework, so happy homeworking, and I will see you next time.